Welcome to the DIY Honda Garage channel. The DTC P16F3 relates to a problem detected in the starter cut relay 1 control circuit of the Honda Civic models from 2011 to 2015. This diagnostic trouble code indicates that there is low voltage in the circuit that controls the starter cut relay 1. The starter cut relay plays a crucial role in the vehicle's starting system by allowing or preventing the starter motor from turning based on input from the powertrain control module, PCM. The relay itself is usually located within the underhood fuse relay box, which houses several critical electrical components. A malfunction in this relay or its circuitry could prevent the engine from starting, leading to operational issues. When diagnosing this code, it is essential to ensure that the vehicle's electrical system is functional and that all connections are secure and free of corrosion. The DTC P16F3 signifies a low voltage condition detected in the starter cut relay 1 control circuit. The starter cut relay is a pivotal component in the starting system of your Honda Civic, and it's tasked with controlling the flow of electricity to the starter motor based on signals from the PCM. Specifically, this relay is located within the underhood fuse/relay box, an area that may also contain other relay and fuse components essential for vehicle operation. When low voltage is sensed, the vehicle may fail to start, and this error code is triggered. Understanding the role of the starter cut relay helps you pinpoint the issue more accurately, as it provides insight into where the problem may dwell, whether it be in the relay itself, the control circuit, or the PCM communication. Several possible causes could lead to the triggering of DTC P16F3. One common reason is a faulty starter cut relay, which may not function correctly due to internal failure. Damaged wiring in the starter control circuit can also result in low voltage conditions. The wiring may have frayed, shorted, or broken connections that disrupt electrical flow. Poor connections at critical points, such as the starter cut relay and PCM, can lead to inconsistent voltage readings, further complicating the situation. Additionally, a defective PCM could misinterpret the signals or fail to send appropriate commands, leading to low voltage at the starter cut relay. Each of these areas should be systematically checked to determine the root of the issue. The primary symptom associated with DTC P16F3 is that the engine will not start. This failure is typically due to the malfunctions in the starter cut relay or the control circuit, preventing the starter motor from receiving the necessary signal to engage. Other related symptoms may include various electrical anomalies, such as flickering dashboard lights, or erratic behavior from electrical components due to inconsistent voltage levels. Drivers may also notice warning lights illuminating on the dashboard, which often indicates that the vehicle's onboard diagnostic system has detected an issue requiring attention. Recognizing these symptoms early can be crucial in preventing further damage or operational failures. The first step in troubleshooting DTC P16F3 involves checking the engine's starting condition. To begin, attempt to start the engine of the Honda Civic. If the engine starts successfully, it suggests that the problem may not be persistent at this time. However, if the engine fails to start, this indicates an ongoing issue that requires deeper investigation. This initial check is crucial, as it sets the foundation for further diagnostics, leading directly into the next step if the engine does not start. It's important to document the result of this step, as it helps guide the technician in identifying whether the fault is intermittent or constant, thereby shaping the subsequent troubleshooting approach. Next, to proceed with problem verification, press the engine's start-stop button to select the off mode to reset the vehicle's electronic systems. Once in off mode, press the engine's start-stop button again to move to on mode, which activates the vehicle's electrical components without starting the engine. Using the high-tech diagnostic system, HDS, clear the DTC from the system to eliminate any historical errors. After clearing, check for any pending or confirmed DTCs with the HDS. If DTC P16F3 reappears, it confirms that the failure is persistent, allowing you to move on to further diagnostic steps. If it does not appear, it may suggest an intermittent problem. Thus, checking connections and terminal integrity at the starter cut relay and PCM is advisable. The next troubleshooting step involves a shorted wire check focusing on the ST cut relay CL line. Begin by pressing the engine start-stop button to select off mode before using the HDS to jump the SCS line, which protects the vehicle's circuits during diagnostics. Disconnect the PCM connector A, 51P, and the starter cut relay 1 from the underhood fuse relay box to isolate the components. Measure the resistance between test points 1 and 2, specifically looking at test point 1, number 51, PNK, of the PCM connector and body ground. This test checks for shorts or failures within the wire. If resistance measures at 1.0 megaohm or higher, the ST cut relay CL wire is intact. Otherwise, you will need to repair any identified shorts in the wire between the PCM and the starter cut relay 1 to resolve the issue. In step 4, you will perform a starter system check. First, ensure the engine start-stop button is in the on mode, which allows the electrical systems to activate without starting the engine. Then, move the shift lever to either the park, P, or neutral, N position, enabling the vehicle's safety systems to permit starting. Check the data list for the starter relay control return using the HDS and see if the status reads on. If it indicates on, the next steps for diagnosing will proceed further. If it does not indicate on, you should refer to the symptom troubleshooting for the engine not starting, as this may point to another failure area that needs addressing. This step focuses on determining the possible failure area by measuring voltages. Press the engine start-stop button to select the off mode. Utilize the HDS to jump the SCS line again, and then disconnect the PCM connector A, 51P. After this, you will once again press the engine start-stop button to shift to on mode, followed by moving the shift lever to P or N. Measure the voltage between the specified test points, test point 1, located at number 51, PNK, of the PCM, and test point 2, which involves body ground. If battery voltage is present, the IG1 ACG wire is likely operational. If the DTC P16F3 clears after updating or substituting the PCM, you have likely resolved the issue. Step 6 involves checking the IG1 ACG line for faults. To start, press the engine start-stop button to select the off mode to ensure all electronic systems are dormant. Next, remove the starter cut relay 2 from its position in the underhood fuse relay box, which allows you to isolate the components involved further. Once removed, switch the engine start-stop back to on mode. You will then measure voltage across the specified test points. The socket number 3 of starter cut relay 2 and body ground. If you read battery voltage, the IG1 ACG wire is likely functioning correctly. If the voltage is not present, you will need to further inspect the ST cut RLY-CL wire for any open conditions or faults between the PCM and starter cut relay 1. In step 7, you will need to perform a fuse check, specifically targeting fuse number B2, located within the under-dash fuse relay box. Start again by pressing the engine start-stop button to select off mode to ensure all systems are shut down. After that, visually inspect fuse number B210A for any signs of being blown or damaged. If the fuse is found to be in good condition, you can move on to step 8. However, if the fuse is blown, it will require replacement. And you should also check the circuit for any potential shorts to ground, which could have caused the fuse to blow. Proper fuse status is crucial, as it directly impacts the relay's operational integrity and overall starting function. The final troubleshooting step focuses on checking for open wires within the IG1 ACG line. Begin by disconnecting the under-dash fuse relay box connector D32P to ensure you are working with isolated components. Next, remove starter cut relay 1 from the underhood fuse relay box and then connect terminals A and B with a jumper wire to create a temporary connection that simulates relay activation. With these connections made, check for continuity between the test points specified, the under-dash fuse relay box connector D terminal number 10, yellow, and body ground. If continuity is present, this indicates that the IG1 ACG wire is functioning correctly. If continuity fails, repairs are required for any open conditions in the IG1 ACG wire between the starter cut relay 1 and the under-dash fuse relay box to ensure proper voltage transmission. After completing all necessary troubleshooting and repairs, a final verification step is crucial to ensure the resolution of DTC P16F3. Clear the DTCs using the HDS to reset the vehicle's diagnostic memory. Following this, conduct a test drive to confirm that the engine starts reliably under various conditions, checking for any instance of DTC P16F3 reappearing. Pay close attention to how the vehicle responds during ignition sequences. Normal operation without incident indicates successful resolution of the issue. Additionally, confirm that all associated electrical systems are functioning as intended, which ensures that no underlying issues evade detection during the troubleshooting process. This verification step is important to foster confidence in the repair's sufficiency. To prevent future occurrences of DTC P16F3 in your Honda Civic, implementing a routine maintenance schedule focusing on electrical components is critical. Regularly inspect connectors associated with the starter cut relay and PCM to ensure they are free from corrosion and secure. It's also advisable to inspect wiring for any signs of wear, fraying, or damage that could lead to voltage issues. Keeping the PCM software updated is essential, as updates can resolve known bugs and enhance the vehicle's overall functionality and reliability. Staying proactive in your maintenance efforts can not only extend the life of the vehicle, but also ensure its consistent performance over time, reducing the chances of encountering similar diagnostic trouble codes in the future. In summary, DTC P16F3 points to an issue involving low voltage in the starter cut relay 1 control circuit within the Honda Civic models from 2011 to 2015. Key components to investigate include the starter cut relay itself, wiring integrity, and the PCM functionality. The troubleshooting process involves systematic steps to isolate the issue, from trying to start the engine to checking the starter relay and fuses. Finally, thorough preventive maintenance practices, such as regular visual checks and firmware updates, can mitigate the likelihood of recurrence. Achieving a complete understanding of this error code equips technicians and car owners alike with the knowledge to tackle not only this issue, but similar electrical problems that may arise in the future. Please like and subscribe to the channel. See you next time.